Hello students, welcome to the class. We have already discussed about gravitation synopsis and 20 questions already we are done. So let us continue with the next question. The earth is an approximate sphere. If the interior contained matter which is not of the same density everywhere, then on the surface of the earth the acceleration due to gravity will be. See here, what is the question here? So assume that earth is an approximately, it is a sphere. Okay, the interior contains the same density which is not of same density, means the density is not same everywhere. Then on the surface of the earth the acceleration due to gravity. So on the surface of the earth, what happens to the acceleration due to gravity, that we need to calculate here. See, that is, it will be directed towards the center, but not the same everywhere. Will have the same value everywhere, but not directed towards the center. Will be same everywhere in magnitude, directed towards the center. Cannot be zero at any point. So here, what happens to the density, acceleration due to gravity, if the density is not same. See here students, if the density is same, what happens? If the density is same, the acceleration due to gravity will be same everywhere. As the density they have specified, it is not same, then what happens to the acceleration due to gravity? It cannot be zero at any point. It cannot be zero at any point. Therefore, the correct option is option D. Option D is the correct option here. Is it clear? Okay, and let us continue the next question. As observed from the earth, the sun appears to move in an approximate circular orbit. So as observed from the earth, the sun appears to move in an approximate circular orbit. For the motion of another planet like Mercury, as observed from the earth, this would. Okay, so what they have said, that is, as observed from the earth, the sun appears to move in an approximate circular orbit. Okay, so sun approximately appears in a circular orbit for the motion of another planet like Mercury, as observed from the earth. So this would. So what happens here? When you observe from the earth, the sun appears moving in a circular orbit. Okay, for the another motion of planet Mercury, what happens for this motion? Okay, so what happens here? It will be similarly true. Option B, not be true, because the force between the earth and the Mercury is not inverse square law. Then third option is not be true, because the major gravitational force on Mercury is due to the sun. Option 4 is what? Not be true, because Mercury is influenced by forces other than gravitational force. So here option C is the correct one. That is not be true, because the major gravitational force on Mercury is due to the sun. So here we cannot predict whatever the conclusion it is given in the question from the earth, because the gravitational force on the Mercury is due to the sun here. Right? So that is option C is the correct option. Let us see the next question. That is, acceleration due to gravity on moon is 1/6 of the acceleration due to gravity on earth. If the ratio of densities of earth is rho m and moon is rho e, then rho e divided by rho m is equal to 5 divided by 3. Then the radius of moon Rm in terms of Re will be. So what they have asked you? They have asked you that acceleration due to gravity on moon, how much they have given? It is 1/6 of the acceleration due to gravity on the earth. Right? If the ratio of densities of earth and moon is, it is rho e divided by rho m, which is equal to 5/3, then radius of moon Rm in terms of Re will be the ratio you need to calculate. We need to calculate the ratio here. See, so acceleration due to gravity, that is G is equal to acceleration due to gravity, that is G is equal to, it is 4 divided by 3 pi into rho into G into R. This is what acceleration due to gravity equation. Okay, so from this equation, what we can say, that is G is proportional to density into R, density into R, or we can also write it as, GM divided by GE is equal to, rho M divided by rho E and Rm divided by Re, right? So we know that acceleration due to gravity in terms of density, we have the equation G is equal to 4 by 3 pi into rho into G into R. We can write G is proportional to rho into R. Therefore, we can write it as Gm divided by Ge is equal to rho m by rho E into Rm by Re. Right. So this is the relation between what? Acceleration due to gravity, density, and the radius here. So now we can substitute the value. So what they have given here, that is Gm divided by Ge is equal to, sorry, they have asked our radius relation, no? So what we need to do here, so radius Rm divided by Re is equal to, it is Gm divided by Ge, then next it is rho E divided by rho m. Okay, means here keep this here only, then if you transfer, this becomes rho E divided by rho m. This is equal to, so what they have specified, see, the acceleration due to gravity on the moon is 1/6 of acceleration due to gravity on the earth. Can I write like this relation? That is 1 by 6 into G. Suppose G is acceleration due to gravity on the earth, then I can take it as 1 by 6 of G. So that is this bracket. Next. So next here it is density. So for density, what they have given, see, if the ratio of densities of earth and moon is, so how we can write it for earth and moon? It is given as 5 by 3. It is already given in the question for rho E divided by rho M, that is 5 by 3. So what happens here now? So G will get cancelled. Therefore, you are getting it as 1 by 6 into 5 divided by 3. That is nothing but 5 divided by, how much you will get? That is 5 divided by 18. We will get it as 5 divided by 18. So this 5 divided by 18 is what it is? It is Rm divided by Re is equal to 5 divided by 18. Therefore, I can write Rm is equal to 5 divided by 18 into Re. So like this we can write it. Rm is equal to 5 by 18 into Re. So the correct option is option A is the right option here. Option A is the right option. So very simple question, but we need to understand the meaning of the question here. That is what? Acceleration due to gravity on moon is given as 1 by 6 of acceleration due to gravity on the earth. Right? If the ratio of densities of earth is rho m by moon is 5 by 3, then radius of moon Rm in terms of Re will be. So Rm in terms of Re is given as 5 by 18. It is 5 by 18, right? So this is how we can simplify this. Next question, that is the acceleration of a body due to the attraction of earth at a distance 2r from the surface of the earth. So here the question is what? That is the acceleration of the body due to the attraction of the earth is at a distance of 2r. So we know that at a distance of r, it is given by G. So at a distance of 2r, what is the value? Let us see this. Okay, so if you simplify this, we know the formula. That is given by G dash divided by G is equal to R divided by R plus H whole square is equal to R divided by R plus 2R, that is H value, to whole square. So this is equal to what we can write. This is equal to, we can write it as r divided by, it becoming 3r. It is becoming 3r here. So r will get cancelled. Therefore, you will get it as 1 by 3 whole square. So 1 by 3 whole square is how much? It is 1 divided by 9. Therefore, we will get it as g dash is equal to, it can be written as g divided by 9. G dash can be written as g divided by 9. Okay. So that is option A is the correct option here. Option A is the correct option. G divided by 9. A option is right. Okay. So when the h value becomes 2r, so when the on the surface of the earth, the expression is written as, it is only r divided by height, means it is only r. Okay. When the height means from the surface of the earth, if it is at a distance of 2r. So I'll just show you the figure how we can take it. That is, so suppose if you assume this as the radius of the earth, so this will be the what it is, radius. Then from this surface, this is at a distance of again 2r. So like that we need to substitute here. Okay. So after substitution, we will get it as g dash is equal to g divided by 9. That is option A is the right option again. Let us see the next question. The depth at which the effective value of acceleration due to gravity is g by 4 is, so at a depth, the effective value of acceleration due to gravity, when the depth is not d, when it is g by 4. So we need to take the formula of g by, means related to depth, the question formula should be taken. That is g dash is equal to g into bracket 1 minus d divided by r. This is equal to g divided by 4 into bracket g into bracket 1 minus d divided by r. So g will get cancelled. Therefore, we will get it as d is equal to. So how we can simplify? G we can cancel. Then we can take it as 1 by 4 is equal to. So it can be written as 1 by 4 is equal to 1 minus d by r. So I'll just transfer this. D by r is equal to 1 minus 3 by how much it is? That is 1 by 4. Sorry, this is 1 by 4. So 1 minus 1 by 4. 1 minus 1 by 4 is nothing but what? It is 3 by 4. That is what d is equal to we require. Therefore, d is equal to, it is becoming d is equal to 3r divided by 4. It is becoming 3r divided by 4. That is option B is the correct option. Option B is the correct option here. Okay. Next question. The depth d at which the value of acceleration due to gravity becomes 1 by n times the value at the surface is. So what it is as, the depth d at which the value of acceleration due to gravity, it becomes 1 by n times the value at the surface is. See here how to do this one. That is, so again the same formula for the previous question what we have used, that is g dash is equal to g into bracket 1 minus d divided by r. So here what they are saying, that g is becoming g divided by n, 1 by n times, that is equal to g into bracket 1 minus d divided by r. Therefore, this implies how we can write? We can write it as d by r is equal to, can I write it as 1 minus 1 divided by n, because g will get cancelled. Again the simplification. So after simplification, if I take d is equal to, it is becoming n minus 1 by n into r. Therefore, the correct option is, that is option B. Option B is the correct option here. N minus 1 divided by N, that is into R. Option B is the correct option. Is it clear? So we need to understand the meaning of the question so that the simplification will be very easy, right? Next question. If Earth stands still, what will be the effect on man's weight? That is, so what happens here when the Earth see it increases, decreases, it remains same? None of these. Which answer is correct here? See what happens when the Earth stops suddenly. The centrifugal force on the man becomes 0. So centrifugal force becomes 0. So its effective weight. What happens with the effective weight? It increases. So here when whatever the centrifugal force and the gravitational force is acting on a body, because of that one weight will be given to the particular person. So when the centrifugal force goes, when the Earth stops, so when it stops suddenly, the centrifugal force goes. That time what happens? The weight of the person, it increases. It shows increased weight. Okay, so option A is the correct option here. Okay, the option A is the correct option. Let us see the next question. If the angular speed of Earth is increased so much that the object starts flying from the equator, then the length of the day will be nearly. So what happens to the length of the day if the angular speed is increased when the object starts flying from the equator? So the answer is given as 1.5 hours, 8 hours, 18 hours, 24 hours. What happens to the length of the day? Okay, when the angular speed is increased for the Earth. So the correct option is, we need to solve this one. Okay. So we can take the equation of time of period. If we take the equation of time of period, it can be solved as, that is, time period of the is given by, it is 2 pi root of r divided by g. So that is equal to, so 2 pi is constant, g is constant, that is acceleration due to gravity. Our radius of the Earth is also constant. So if you substitute and simplify, you will get it as 1.40 r. So you can see here 1.40 is not given. So this can be nearly equal to what? 1.5 r. The length of the day becomes 1.5 r lengthier. 1.5 r lengthier here when the angular speed of the Earth is increased. Here they have not specified anything particularly what happens, means how much it will increase and all. So therefore we can take this formula and directly we can do the simplification. So the answer is, that is 1.5 r. Option A is the correct option here. Okay, let us see the next question. The escape velocity from the Earth is about 11 km per second. The escape velocity from a planet having twice the radius and the same mean density as the Earth is. So what we need to calculate here? We need to calculate the radius, the escape velocity value we need to calculate. Okay, when the planet having twice the radius and the mean density as the Earth. The radius is more, but the density is same. So let us solve this one. Formula is so formula can be written as escape velocity V is equal to root of 2g into m divided by r is equal to root of 8 divided by 3 into pi into g into rho into r square. So this is what the escape velocity. In terms of density, I have written the formula. As we can see here, the escape velocity is directly proportional to what? It is directly proportional to radius, where it is directly proportional to radius, in the sense here they have specified that the radius is becoming twice. So it is becoming, radius is becoming twice. Okay. So when the radius is becoming twice, the escape velocity also becomes twice here. That is nothing but, if they have given for Earth it is 11 kilometer per second, the other planet which is having twice the radius, the value obviously it becomes 2 times of the value of the Earth, that is 22 kilometer per second. Here again the density value, what happens, they have not specified. They said it is same as that of the Earth. Therefore we can see only the relation between escape velocity and the radius of the Earth. Therefore the correct option is 22 kilometer per second. That is option A is the correct option here. Option A is the correct option. Then next question. The distance of a planet from the sun is 5 times the distance between the Earth and the sun. The time period of the planet is. So here we need to calculate the time period of the planet. So how to do this one? That is, so by using Kepler's third law, the relation is given by. So what all things they have specified in this question? The distance of a planet from the sun is 5 times the distance between the Earth and the sun. Okay, the distance value they have given. The time period of the planet is, what happens to the time period of the planet? See here the according to Kepler's law, we can write T is proportional to R raised to 3 by 2. According to Kepler's law, we can write this. So here the time period of a planet is equal to 5 raised to, it is equal to 5 raised to 3 by 2 into the time period of the Earth, into time period of the Earth. So this is equal to 5 to the power of 3 divided by 2 into time period of the Earth is how much? It is 1 year. It is 1 year. Therefore here, as it is 1 year, therefore the option becomes 5 raised to 3 by 2. So in the options it is written as, it is not 53 by 2, it is 5 to the power of 3 by 2, 5 to the power of 2 by 3, 5 to the power of 1 by 3, and 5 to the power of 1 by 2. So as you see, according to Kepler's law, we have the relation T is proportional to R to the power of 3 by 2. Therefore, the T of planet is 5 times, they have said, right? Therefore, it becomes 5 raised to 3 by 2 into T of Earth, as the T of Earth is, time period of the Earth is 1. Therefore, we can write it as 5 to the power of 3 by 2, right? Next question. In planetary motion, the areal velocity of position vector of a planet depends on angular velocity and the distance of the planet from sun. If so, the correct relation for areal velocity is. So the question is what? In planetary motion, the areal velocity of position vector of a planet, it depends on angular velocity. It depends on what? Angular velocity, that is given by omega, and the distance of the planet from the sun. If so, the correct relation for areal velocity is. So how to do this? That is given by, see here. So according to second law of Kepler, we know that dA by dt, that is areal velocity, is equal to, it is given by L divided by 2m, where L is the angular momentum, m is the mass. So we can write the expression for angular momentum as what? mvr divided by 2m. So m will get cancelled. Therefore, we will get it as, it is actually 1 by 2 v into r. But if you see the option, they have given the question in means equation in terms of angular velocity, right? Therefore, what we need to do here, as we know v is equal to, it is r into omega. Therefore, the equation becomes 1 by 2 v value is what? R omega. That is omega into r square. It is 1 by 2 omega into r square. So if you see the options, the option C is the correct option here. So it is given as, we got it as dA by dt is equal to 1 by 2 omega r square, but 1 by 2 is what? It is constant. Therefore, we can write it as what? dA by dt is proportional to omega r square. dA by dt is proportional to omega r square. Okay. So the correct option is option C. Option C is the correct option. Let us see the next question. That is, two satellites A and B go round a planet P in circular orbits having radii, which is having radii 4r and r respectively. Okay. If the speed of the satellite A is 3v, the speed of the satellite B will be, the speed of the satellite A is 3v and the speed of the satellite B will be. So what will be this value? Okay. So the radius value they have given, if the speed of the satellite A is 3v and the speed of the satellite B we need to calculate. So how we can do this one? That is, orbital velocity of satellite is given by, that is, orbital velocity of satellite is given by v is equal to, it is gm divided by r. So this implies we can write it as v is inversely proportional to what? It is 1 divided by root r. From the equation we can write v is inversely proportional to 1 by root r. So here they have specified for A and B. They have asked for B, therefore I'll take it as VB divided by VA is equal to root of RA divided by RB, because they are inversely proportional. Therefore, the equation becomes like this. So what they have said, it is for this one, for A it is 3V and for B we need to calculate under root of radius. For A is 4R and for B is R will get cancelled. Root of 4 is how much it is? 2. Root of 4 is how much it is? 2. But we want it for VB. Therefore, so VB is equal to what we can write? We can write VB is equal to 2 by 3. VB is equal to, we can write it as, sorry, it is in the denominator. No, so it becomes in the multiplication 3 into V, that is nothing but 6 into V. That is VB is equal to 6V. So here what is the answer? That is, when two satellites go around a planet P in a circular orbit, which is having radii 4r and r respectively, if the speed of the satellite A is 3v and the speed of the satellite B, we need to calculate. Where for A, when it becomes 3v, what happens for this? So option B is the correct option, that is 6v. 6v is the correct option here. Okay. Let us see the next question. If the gravitational force between two objects were proportional to 1 by r, where r is separation between them, then the particle in circular orbit under such a force would have its orbital speed proportional to. See how to do this one. That is, what they have said here. See the question. If the gravitational force between the two objects, so you can assume two objects were proportional to 1 by r, where r is the separation between them. So you can consider two objects, the separation between them. Suppose if it is 1 by, that is r, then a particle in a circular orbit under such a force would have its orbital speed proportional to. We need to calculate the orbital speed. So according to the question, we know that according to universal law of gravitation, we can write F is inversely proportional to r square and V is proportional to, it is 1 divided by root of r into bracket n minus 1. Okay, here n is equal to 1. Here n is equal to 1. Therefore, we can write V is proportional to 1 divided by r raised to r 1 minus 1. So 1 minus 1 is 0. r raised to 0. So what we can write, 1 divided by r raised to 0 means it is in the root. So however you simplify, it is becoming 1 r to the power of 0. That is option B is the correct option here. Option B is the correct option. That is r to the power 0. See here students, everything is power, huh? That is A option is 1 divided by r square. B option is r raised to 0. C option is r. So if you take the orbital velocity expression, the answer is r to the power of 0. That is option B is the right option. Next question. The distance between center of earth and moon is 3,84,000 kilometer. Okay. Right. So the distance between the center of the moon and the earth is 3,84,000 kilometer. If the mass of the earth is 6 into 10 to the power of 24 kg and g is equal to 6.67 into 10 raised to minus 11 Newton meter square per kg square, the speed of the moon is nearly. How to do this one? That is, we know that orbital speed v is equal to, so this is v is equal to under root of g into m divided by r. Substitute the value, g value is, it is 6.67 into 10 raised to minus 11 into m value is 6 into 10 raised to 24 divided by what it is, r. R value is how much? It is 384,000. Kilometer it is given. So I'll convert it in terms of meter, that is 10 to the power of 3. So if you simplify this, that is 6.67 into 10 raised to minus 11 into 6 into 10 raised to 24 divided by 384,000 into 10 raised to 3. So if you simplify this, you will get the value of V as 1.02 kilometer per second, or approximately you can write it as 1 kilometer per second. 1 kilometer per second. Therefore, the correct option is option A is the correct option here. Option A is the correct option here. Okay. Let us see the next question. A satellite is launched into a circular orbit of radius r round the Earth, while a second satellite is launched into an orbit of radius 1.02 r. The percentage difference in the time period of the two satellites is. See how to do this one. That is percentage error we need to calculate. Means options are given in terms of percentage itself. Okay, so here how we can do that is, orbital radius of second satellite is, so if you see the first value is how much, it is r, and the next value is 0.02 r, which means that the orbital radius of second satellite is 2% more than that of the first satellite. I hope you agree with this. So the first satellite orbital radius is r, for second satellite it is 1.02 r. Therefore, here what happens, for the second satellite, the radius is 2% more than that of first satellite. Now here T is proportional to, we have r raised to 3 divided by 2. T is proportional to r raised to 3 divided by 2. Okay, so percentage increase in the time period is equal to, so percentage increase in the time period is equal to, it is 3 divided by 2 into percentage increase in orbital radius, that is equal to 3 by 2 into 2%. 3 by 2 into 2%, that is equal to, so that is equal to, we can write it as 3%. That is equal to, we can write it as 3%, because 2 will get cancelled. Therefore, we will get it as only 3%. According to the relation, we can write T is proportional to r to the power of 3 by 2. Therefore, percentage increase in the time period is equal to 3 by 2 in the bracket, percentage increase in orbital radius, that is 3 by 2 into 2%, that is total is 3%. Okay, so the correct option is 3% here. Option D is the right option. Next question. An Earth satellite S has an orbit radius which is 4 times that of a communication satellite C. The time period of revolution of S is. So Earth satellite is what? It is S, whose radius is 4 times that of the communication satellites. Then what happens to the time period? Then what happens to the time period? So let us calculate this one. So again, Kepler's law, we can use the relation between time period and the radius. That is, see here, it can be written as the orbital radius of the satellite RS is equal to 4 into RC. RS is equal to 4 into RC. So from the Kepler's law, we can write T is proportional to RS to 3 by 2. Then TS divided by TC is equal to. So TS is what? That is time period of the satellite. TC is what? Time period of the communication satellite. The ratio becomes, it is RS to RS divided by RC. RS divided by RC, or we can take SC also. Okay. So this to the power of, it is in common, it is 3 by 2. Therefore, TS is equal to, it becomes 8 TC. It becomes 8 TC. Why? Because here what they have given, it is 4 times that of the ratio. So it becomes that is 4 to the power of 3 by 2. So 4 to the power of 3 by 2 is nothing but 64, root of 64. So root of 64 is how much? It is 8. Therefore, it becomes 8 TC. It becomes 8 TC. As we know that the TC value is, it is 1 day, right? So for Earth it is, therefore it becomes 8 into 1, that is nothing but 8. That is nothing but 8 days. So the time period of revolution for the Earth satellite is 8 days. It is 8 days when the orbital radius is 4 times that of the communication satellite. That is option B is the correct option. Option B is the correct option here. Next question. Potential energy of a satellite. Potential energy of a satellite of mass m and rotating at a height of 6.4 into 10 to the power of 6 meter from the Earth center is. So we need to calculate, that is potential energy of the satellite of mass m and rotating at a height of 6.4 into 10 to the power of 6 from the Earth center is. So how to do this one? That is, see here, potential energy expression we need to take. That is given by potential energy is equal to minus Gm into m divided by R. Okay, so this is equal to minus Gm into m divided by R value is Re plus H. So again, this is equal to minus Gm into m divided by, this becomes 2R into E, as H is equal to what? Re, which is given in the question, Okay. Therefore, potential energy is equal to, it is minus Gre square into m divided by 2Re is equal to, so 1 by 2 is how much? It is 0.5. So 0.5 m G Re square, Re will get cancelled. Therefore, we will get it as minus 0.5 m into G into Re. That is gm is equal to gr square. So what I did here, I have substituted the value of gm is equal to gr square. I have substituted as gm is equal to gr square, right? That is potential energy is equal to minus 0.5 m into g into re. That is the correct option is option A is the right option. Option A is the right option here. So 38. Next question. The time period of a simple pendulum on a freely moving artificial satellite is. So what happens to the time period of a freely moving satellite? See here, here we can prove it, or in general also we can explain. So I'll show you the proof. You can remember this afterwards. See that is the time period equation is, it is 2 pi root of L divided by G dash. It is L divided by G dash is equal to 2 pi root of L divided by what they have said. It is a freely moving artificial satellite. So when it is a freely moving artificial satellite, the acceleration due to gravity will be 0. L divided by 0. Anything divided by 0, what it is? It is nothing but infinity. It is nothing but infinity. Okay. Therefore, the correct option is option D is the correct option. The value of G will be 0 for the satellite, which is moving freely. Okay, so why the satellites will be moving freely? Because the G value will be 0 there, therefore it is moving freely. So when you take G is equal to 0, you will get the time period as infinity. The time period as infinity. Next question. If the radius of Earth contracts 1 by n of its present value, the length of the day will be approximately. So in the previous case, we have seen one similar problem, but that is for the by comparing the time period of two different planets. Here we are taking only for Earth when it contracts 1 by n times of its present value. So how to do this one? That is, it is given by, we know that L is equal to I into omega. L is angular momentum, I is moment of inertia, omega is angular velocity. So this is equal to, I value is, it is 2 by 5 into m r square into 2 pi divided by t. Okay, so this is equal to, it is constant. This is equal to, it is constant. Therefore, we can say that t is proportional to r square. This we know already. Okay, so angular momentum I have written in terms of what we can say, moment of inertia. I have written the expression, that is I is equal to, it is 2 by 5 m r square, because Earth we consider it as a sphere, into omega value is 2 pi divided by t. Here all the values are constant, therefore t is directly proportional to r square. So what we can write here now, t2 divided by t1 is equal to, it is r2 divided by r1 raised to square. This is equal to r divided by n divided by r whole square. So this is nothing but r will get cancelled. Therefore, we will get it as 1 divided by n square. 1 divided by n square, that is t2 divided by t1 is equal to. So t2 is equal to, so t1 value is how much? It is 24 hours. Therefore, 24 divided by n square into h what I have written here, it is r here. Means it is hours. It is in terms of hours we have written the answer. That is 24 by n square is the answer. Therefore, the correct option is C, 24 by n square, where it is. So option A is 24 by n, option B is 24 by n square, option C is 24n, and option D is 24n square. So the correct option is option B is the correct option. Option B is the correct option here. Next question. The escape velocity for a planet is VE, it is VE. A tunnel is dug along a diameter of the planet and a small body is dropped into it at the surface. When the body reaches the center of the planet, its speed will be. So what happens to the speed? We need to calculate when the planet having escape velocity VE and a tunnel is dug along the diameter. Okay. So, and for a small body which is dropped into it at the surface, when the body reaches the center of the planet, its speed will be. So, let us calculate this. That is given by the gravitational potential at the surface is given by, it is Vs is equal to minus G into M divided by R. It is Vs value. Then gravitational potential at the surface of the earth is given by Ve is equal to minus 3 into G into M divided by 2R, right? For the planet and for the earth, we have written it. Next, what we need to do? So by the conservation of energy, we can write it as, that is kinetic energy is half mv square, because when it is dropped, it acquires the kinetic energy. So here this equation becomes m into bracket Vs minus Ve. That is difference in the velocity. Therefore, simplify this equation for V square is equal to, it becomes 2 into Gm by R into bracket 3 divided by 2 minus 1. So this is equal to, again further if you simplify, we will get it as Gm divided by R, because 3 by 2 minus 1. Okay, into 2. So 2 will get cancelled. Then here if you simplify this, you will get it as Gm divided by R. Gm divided by R or can also be written as Gr. Why? Because Gm is equal to Gr square. R will get cancelled. Therefore, we will get it as Gr is equal to Ve square divided by 2. It is Ve square divided by 2. Why? Because we know that Ve, the escape velocity, is equal to root of 2g. It can be written as root of 2g into r, right? Therefore, squaring on both the side, it becomes V square is equal to 2gr. Therefore, gr is equal to what it is? V divided by 2. It is V square divided by 2. Therefore, we will get it as V is equal to V E divided by root 2. We will get it as V square is equal to V square divided by 2. Therefore, VE is equal to what it is? V is equal to VE divided by root 2. That is option B is the, sorry, D is the correct option. VE divided by root 2. Okay. Let us see the next question. A body is released from a height h, takes time t to reach Earth's surface. The time taken by the same body which is released from the same height to reach the moon's surface is. Okay, so here we need to calculate the time. So the question formula is, if the body falls from height h, then the time of descent is given by t is equal to root of 2h divided by g. So here for moon divided by for earth, this is equal to, that is g of earth divided by g of moon. This is equal to root of 6. Therefore, we can write it as T of moon is equal to root 6 of T of earth. That is root 6 into T. Root 6 into T. That is option D is the correct option. Okay. Option D is the correct option here. Next question. A satellite is revolving around the earth with orbital speed v0. If it stops suddenly, the speed with which it will strike the surface of the earth would be. Okay, so we need to calculate the orbital speed. Okay, so orbital speed is given by. So here we can assume that by applying the conservation of mechanical energy between body A and B, we can write it as minus G m into m. This is what potential energy by R is equal to kinetic energy is half mv square plus. So the orbital speed I am writing in terms of gmm by R. Okay. So here we can simplify this equation for half mv square. So this is plus. Okay, this is plus. So if you transfer this, it becomes, so this is becoming g m by m divided by capital R minus g m by m divided by small r. Okay, so I can simplify this equation for v square is equal to, I can simplify this for v square is equal to, it is becoming 2gm divided by r minus 2gm divided by small r. Okay, so this is equal to, so this is equal to what we can write next step, we can write it as ve square minus 2ve naught is equal to this given equation, right? Therefore v is equal to under root of ve square minus 2ve naught square, 2ve naught square, where v is what? Escape velocity, that is given by 2gm by r. Orbital velocity is given by gm by r here. Therefore the option D is the correct option here. Understood? That is conservation of energy concept we need to use here, and we need to simplify the equation. That's it. The next, during the journey from Earth to the moon back, the greatest energy required from the spaceship rockets is to overcome. See, the gravity, why we require more energy here? The Earth's gravity at takeoff, the moon's gravity at lunar landing, the moon's gravity at lunar takeoff, the point where the pull of the Earth and moon are equal but opposite. That is option A is the correct option here. Option A is the correct option here. Okay, students. So this completes all the numericals on gravitation. So we are done with the gravitation chapter now. In the next class, let us continue with the new topic. Thank you.